Hey guys, so today we're going to be talking about some more nervous system. Last video we talked about the peripheral nervous system, and we talked about the sympathetic and the parasympathetic divisions. Now, I wanted to look a little more into that with what's going on between the preganglionic neuron and the postganglionic neuron. What's happening between those synapses, the acetylcholine and those nicotinic receptors. So right here, I have drawn a terminal bouton from the preganglionic neuron synapsing with a dendrite from the postganglionic neuron. Now, another way that we can call these is the pre-synaptic membrane for the terminal bouton and the post-synaptic membrane for the dendrite. The area in between them is known as the synaptic cleft, and that's how the neurotransmitter is going to travel from the pre-ganglionic neuron to the post-ganglionic neuron. Okay? Now, looking more into it, it all starts when we have an action potential. The action potential is going to propagate down to the terminal bouton, and it's going to cause the voltage to change. That change in voltage is going to cause these voltage-gated calcium channels to open up. When they open, it's going to cause calcium to rush into the terminal bouton. When it rushes in, it joins with synaptotagmin and forms a calcium synaptotagmin complex. I know it's a lot of words. I know you guys can memorize it. That calcium synaptotagmin complex can cause the fusion of the synaptic vesicles. And there's a couple steps involved in that. So first, the synaptic vesicle will dock, then it will fuse, and then it will exocytose in a quanta of neurotransmitter. So what these synaptic vesicles do is they hold the neurotransmitter. And in our example, our neurotransmitter is acetylcholine. So it's not just one, it's more than one. It's a quanta. So that quanta will be released into the synaptic cleft, and then the acetylcholine can go to the nicotinic receptor, right? The nicotinic receptor is the acetylcholine receptor, and it will bind to acetylcholine. That will cause the nicotinic receptor to open and will allow the influx of sodium ions. Those sodium ions will come in to the dendrite on the postsynaptic membrane. Okay? It will also allow a little bit of potassium to leave, but not too much. Now, how are the acetylcholine taken off? The acetylcholine are taken off by acetylcholinesterase. That's found in the synaptic cleft, and it's produced by the postsynaptic membrane. Okay? Now, with the influx of sodium that we have, if we have enough sodium coming in, then we're going to cause EPSPs, excitatory postsynaptic potentials. And if we have enough excitatory postsynaptic potentials, they can be summed up, and if we have enough, we can create a threshold stimulus that causes an action potential. So these EPSPs are graded potentials that can be summed up and then can cause another action potential. Now, the threshold stimulus that we're going to need is about 15 to 10 millivolts depending on the size of the neuron. I hope this cleared it up a little bit more, and thank you guys for watching.